Hey, hi YouTube. I hope you all guys are doing great. In this video, we are going to cover LCEL, which is also known as LangChain Expression Language. I will explain you what actually is this LCEL, why we need it, with some examples. Then we will look into some code, and also we will see some advantages of it. So first of all, let's see what actually this LCEL is. So it stands for LangChain Expression Language. It is a powerful tool designed to seamlessly integrate and compose complex chain of tasks for simple like prompt plus LLM chains to intricate workflows with hundreds of steps. Okay, I can give you some more idea. Like, it is an integrated feature within LangChain that allows language models to execute arbitrary code. It essentially enables dynamic code execution capabilities within a conversational AI framework. Okay, lot of different features in LangChain you can implement without LCL, like streaming, invoke, asynchronous execution, but the length of code will be like a lot. Like if you are having 100 lines of code in LangChain to execute these features like asynchronous call or invoke or maybe streaming, but with the use of LCL, maybe you can execute this all things in 30 line of code because they have already implemented it. Okay, so that's why it's very important to follow it, and definitely it gives us a production ready code from initial days, and also it's a good practice to follow this LCL syntax while creating LangChain applications. So let's see what are different things that LCL provide. So first one is, we call it as streaming support. Okay, so first one is streaming support. Imagine you are building a chatbot that needs to respond quickly to user queries. With LCL, the time to first token is optimized. Okay, what I mean by time to first token is meaning that users start receiving the response almost immediately. For instance, if you are streaming response from an LLM to a real-time parser, the user see parsed output at the same rate the LLM generates token. Okay, so it's very helpful whenever you are creating some applications that where you want the time to first token needs to be optimized. Okay, then second one is, I will show each and everything in code also, but let me cover the theory part. Okay, because it is also important. So second one is asynchronous support. Async support in LCL allows you to build chains that can be executed asynchronously, meaning that the chains can run tasks without waiting for the previous task to complete. Okay, this is beneficial for performance and scalability, particularly when you need to handle multiple tasks or requests simultaneously. Okay, then optimize parallel execution. So it is also very important. Okay, whenever you are creating some big LLM applications. So consider you are building a system that retrieves document from multiple sources. So LCL automatically execute these retrievals in parallel, reducing latency significantly. This parallel execution is available in both synchronous and asynchronous mode, ensuring your chains runs in an effectively way as possible. Okay, then we have the retries and fallbacks. So definitely if you are in this LangChain or LLM Gen AI application development path, then you might have also encountered that it's not like every time LLM will give you the correct response. So a lot of time you have to make the retry. For example, you want a JSON data in a particular format, so there are chances that the LLM will make mistakes. Okay, so to enhance reliability on LLM, LCL allows you to configure retries and fallbacks for any part of your chain. For example, if one step fails, the chain can automatically retry or switch to an alternative method without interruption. This is crucial for maintaining robustness at a scale. Okay, Then some more parts are also there, like this is access um, intermediate results. Okay, by the name it is clear. So for complex chains, accessing intermediate results before the final output can be invaluable. Suppose you are developing a multi-step data processing chain. You can stream intermediate results to provide users with progress updates or to debug issues early in the process. So this features is available on every LangServe server. So there are two things like LangServe and LangSmith, which is very important, where LangSmith is used mostly for tracing. Okay. So then we have input and output schema. This is very useful, and this is very important. Okay, I have used in my development journey a lot of time. So input output schema. So LCL chains come with pydantic and JSON schema for input and output validation. For instance, if you have a chain that processes user data, this schema ensures that all inputs and outputs are correctly formatted, preventing errors and ensuring data integrity. Then the most important is tracing. Okay, a lot of people will ignore it, but it's really important whenever you are creating application for your clients. So as your chain grows more complex, understanding each step's operations become essential. LCL automatically logs all the steps to LangSmith, providing detailed observability and debuggability. This means you can trace the exact flow of data and operations, making it easier to troubleshoot and optimize your chain. So whenever you are creating an application, you want to see like where actually the calls are going, how much time it is taking, what the output we are getting. So this all can be done by the tracing part. You can use LangSmith for it, or there are a lot of things like Jigger and all things are also there where you can trace all this LLM call. So in summary, LCL is designed to take you from prototype to production with minimal code changes, offering robust features like streaming support, async execution, parallel processing, detailed tracing. Whether you are building a simple chatbot or a complex data processing pipeline or chatbot, LCL ensures your chain are efficient, reliable, and easy to manage. Okay, so you might ask that this all features before LCL, does they exist or not? Yeah, they existed, but you have to write a lot of codes. But because of this LCL, they already comes within a package, so it's very easy to use this without writing a lot of codes. Okay, so if you write less number of code, there is less chance of failure. Okay, so this all are very important. Let me show you in the code this all things. Okay, and also the power of LCL, so that you will understand why LCL is important. So let's move to the code. So here first of all, I am loading the environment variables because I have stored this LangChain API. So this is the correct API OpenAI key, and this is an incorrect API key which I have just added in purpose. Okay, so let me run this cell, and then we are importing some basic stuffs like standard output parser, chat prompt template, system message prompt template, LLM chain, very basics. Okay, I know this LLM chain is now depreciated, but I am using it because I want to show you that without LCL how you are creating the chains and invoking it. So basically we are going to create a rap song within 50 words. So this was the trivial way, how you created the prompt. So this is the create prompt definition of method, very easy. Okay, we are passing a prompt, then a system message prompt where we are passing the instructions, then a human message prompt template where we are passing the user input, and then we are creating a template and just returning the prompt. Okay, so this is if we pass UFC, so the prompt will look like this. Okay, so here there will be user input, and this is how a prompt look like. Okay, so I think you know already these things because this is a very basic LangChain stuffs. So if you don't know about it, you can watch my videos. Okay, and this is the correct way of creating prompts also, to create dynamic prompts. Okay, then we are creating a parser, and this is the trivial way how you were creating the LLM chain. So LLM chain is equals to LLM chain, then you pass the model, then the prompt, and then the output parser. It's optional output parser, but it's really useful. If you don't know about output parser, just learn about it. I have also made a video about it. Then LangChain.invoke, and then we are passing the exact keyword that we want to the keyword that for which we are trying to create the um, rap song. Okay, so it will create, the user input is UFC, and it has created a very beautiful rap song. Okay, so this was the trivial way, the way you were creating LLM chain. But with the help of LCLC, how small the syntaxes became. Okay, so see, this is how you can create a chain very easy. So chain is equals to final prompt, then there is a Unix pipe operator, then model and output parser, and then just chain.invoke UFC, and you will get again a very beautiful rap song. Okay, so very see how easy it became with the use of LCL. Okay, so the symbol, like this is this one. Okay, this symbol is similar to Unix pipe operator, which chains together different components, feeding the output from one component as input to the next component. So the output of final prompt will move to model, and the output of model will move to the output parser, and then we will get the final output. So let me explain you what actually the flow will be. So whenever we pass this topic, which is user topic or user input, as UFC, so the prompt component takes the user input, which is then used to construct a prompt. After using this user input to construct the prompt, then the model component takes the generated prompt and passes to the LLM. Like in this case, I am using OpenAI LLM. You can use any kind of LLM. Okay, so this will be passed to the LLM model for evaluation. The generated output from the model is an object which will be passed to output parser. Finally, the output parser component takes the message or the object and transform into a Python string, which is finally visible to you. Okay, so I think this much is enough, but let me explain you a bit. So if you see, this result is equals to final prompt dot invoke a mobile. I am passing it. Okay, so if you see it, so let's print this. We are printing this result and or the response and the type of response. Why I am showing you is because if directly if you pass whatever message you are having directly to this prompt template or the final prompt, okay, which is this one. This is the final prompt, which is of this type, okay, which is of chat prompt template type. So if you pass it, you will get a simple created prompt where at the end there will be the topic will be written, because this was the prompt that we have passed, like create a rap song on a given topic within 50 words. This was the instruction, and the topic will be the user input. So here you can see the topic and the instructions. Okay, and this will be of chat prompt value type. Okay, now we will combine two things with using that pipe operator, the final prompt and model. So the output of final prompt will be passed as input to the model. Okay, now let's see what will happen. So this will now become a group. Okay, so final prompt pipe operator model dot invoke mobile. So first of all, this will be created, and then it will be passed to the model, and model will give us the output. So here see, the content is equals to riding through the city with my mobile in my hand. Okay, this is just a rap song. Okay, so if we are printing the response, now it became a AI message. Okay, because whatever the LLM model returns, it is of AI message type. Okay, now let's combine three things like final prompt, model, and output parser. So final prompt will give this as output to the model. Now model will give AI message as output to the output parser, and output parser gives us a string which is visible to all of us. So this is one of the this is a group where final prompt, the model, and output parser dot invoke mobile. So first of all, it will create a Basically it will create a chat prompt value, then AI message, and then the finally output parser will convert it into a string. So here you can see it is a string, and this is how the very beautiful rap song is here. Yeah, I'm always on my phone, can't deny, scrolling through the apps, time flies by. Okay, so that's why we should limit our phone usage. Okay, so this is how basically the LCL makes life very easier. Okay, so this is what it's called as chain. So if you observe, this was actually initially I have used as chain. So this is I have just break down the all the steps, so like what happens at each step. Okay, this is how you should also learn. Now let's see some features of LCL. Like there is a streaming feature. Okay, so let me just I guess I have run it or not. So let me also run it because I have earlier run it. So let's see. Okay, so now let's see what actually streaming is. Just keep focus here. So this is what streaming is that I was explaining. You see, one by one everything is coming. Okay, so this is very important. Like whenever you are building a chatbot that needs to respond quickly to the user query, like time to first token should be optimized. Then there is batch processing. So batch processing is like, let's suppose you are giving more than one inputs and you want the answer. So let's suppose I want a rap song on water, air and land at the same time. So this is what batch processing does. So it has created a rap song with water, then for air, and then for land. Then asynchronous invoke. So it is also very important, like whenever you want asynchronous way to invoke, okay, whenever you don't want the answer at this at that time particularly. So this asynchronous invoke is like this: await chain.a invoke, and you can pass the whatever you want. Then there is asynchronous batch processing also, like batch processing and asynchronous you can mix it, so it's also quite easy. Then also runtime model selections are also there, like at the runtime you can select the models, like maybe at some point you want the GPT 3.5 turbo, at some point you want anthropic model, at some point you want Google models. So it depends. So you can also do this runtime model selection with the help of LCL. Then logging with LangSmith, we know logging is very important. So this logging you can also do it using LCL with LangSmith. Okay, so it's quite easy and handy because we know that all these things are really important whenever you are creating a Gen AI application or LLM based application. Then fallbacks. So this is why I have created this model. Okay, so this one is a fake one. Okay, there is no key. There is a key called OpenAI API key which is incorrect. Okay, so I have created two models. I know both are same, but this one is incorrect and this one is correct. Okay, so what actually this fallback does is so it has created a chain 1, and already we were having a chain. So the chain was, if you see here, actually the chain was having model. So this was the correct model, and now in chain 1 I have passed the model 1 which is the incorrect one. Okay, so this is incorrect chain and earlier one was correct one. So fallback chain is equal to chain dot with fallbacks chain 1 and chain. So what actually this is, so you can think this is one model and this is one model. Okay, currently both are of GPT 3.5 turbo, but maybe this model can be from another provider like maybe Anthropic, and this can be from OpenAI. Now maybe at some point of time Anthropic models may be down. Okay, at that time you need to switch to the other options like GPT 3.5 turbo or OpenAI models. So this is what fallback models does. So if I will run it, I am just making two calls, invoke and batch. Okay, I know I have already explained what actually invoke and batch is. Okay, now what actually I want to show you here is this chain 1 is nothing, it is wrong. Okay, if I just if you are not believing me, let me show you. Okay, so if I just add chain dot invoke and let me pass it as Japan. Okay, so this chain is the correct one because we have passed the model. Okay, not the model 1, means the correct API key for OpenAI model. Now chain 1 dot invoke and I'm passing it as Dubai. Okay, now sorry, so see, this is authentication error because we have added incorrect API key. Okay, so this is what I want to show you, that fallbacks are very useful when you are trying to switch between the models based on the availability of this model. So this is very quick and very easy to use. Okay, so these were all about LCL, not all but the basic introduction about LCL. Now I want to also show you that without LCL, if we are trying to just add a I just want to add, let's suppose I want to implement a very basic application which is having all the supports, like it will have the call chat model, invoke chain, streaming the responses, then batch chain, then invoke LLM chain, then maybe like streaming, batch, invoke, and also like loggings, and a batch configuration, asynchronous call, and all these things. See how much long this program is, like literally like around 160 lines. I have taken this program from LangChain website only. Okay, so this is of 160 line. Now if we want to achieve the same functionality using LCL, so let's just see how easy it is. So it is now like only 35 lines, and all things you can easily achieve, like whatever you were seeing in without LCL, you can with this like around 160 lines you can achieve the same functionality with a very cleaner code and very less number of lines, like only in 35 lines. So that is the power of LCL. That's declarative way of writing the LangChain applications. So this is I wanted to share with you. Then what are the advantages of LCL? So LCL simplifies app development by integrated LLMs and related components, like unified interface. Like every LCL objects adheres to runnable interface. In some videos I will cover what actually is runnable interface. Enabling consistent invocation methods, like everything, like you might have seen that prompt was also having invoke, chain was also having invoke, model was also having invoke. Okay, so they all have invocation methods like invoke, batch, stream, and all of them that I have already discussed. This is standardization supports operations such as batching and streaming within LCL chains effectively and also effortlessly, like you don't have to put a lot of efforts. Then composition primitives, like LCL offers primitive for composing chains, like parallel components, implementing fallbacks, dynamically configuring the chain internals, and more. So these tools facilitate a complex workflow within maintaining flexibility. So definitely it's a very good thing to learn and also to follow in your ahead journey wherever you are creating LLM applications, like you are creating chains, agents, and all things. So with less number of codes you can, and also having a very clean code, you can achieve a lot of functionalities. So that's all. If you have any doubt about LCL, let me know in the comment section, and also let me know if you like this video or not. And in upcoming videos we are going to see a lot of different things like learnable interface, and then also the primitives of this LCEL. So a lot of things are going to come, so please hit the subscribe button, and if you like this video, please share with your friends also. Okay, and let me know if you have any doubt about LCL, and I hope you will use this LCL in your further journey wherever you are trying to develop a LLM or LangChain based applications. Thank you. Meet you in the next video. Till then, bye bye.